You ever just stop and wonder, why are we here? It's probably the biggest question you can ask, but for physicists and philosophers, there's a slightly more pointed version of that question. Why does our universe seem so perfectly, so impossibly set up for life to exist? Are we just the result of a cosmic accident, or is there some kind of deeper design at work? Let's really dig into the evidence.
So, to really get a handle on this problem, let's try a little thought experiment. Imagine you spill a box of Scrabble letters on the floor. It's just a random mess, right? You'd think nothing of it. But what if you look down and the letters spelled out to be or not to be? You'd know instantly that wasn't random. Well, the fine-tuning of our universe feels a lot like finding that line from Hamlet. It just seems way too specific, way too improbable to be a coincidence.
So just how improbable are we talking about here? Well, the brilliant physicist Roger Penrose actually did the math. The odds of our universe just happening to start with the low entropy, super orderly conditions needed for life to eventually emerge were 1 in, well, look at that number. That's 10 to the power of 10 to the 123rd. To give you some perspective, there aren't enough particles in the entire known universe to even write that number out as a 1 with all its zeros. The odds are so ridiculous, it basically forces us to ask, what is going on here?
And that incredible number? It's not just a one-off thing. Physicists have found that this kind of fine-tuning is woven into the very fabric of reality. It's a genuine cosmic puzzle, and it's one that seems to demand some kind of explanation.
This puzzle really has 3 main parts. First, you've got the laws of nature themselves. The simple fact that a force like gravity exists is what allows stars and planets to form in the first place. Second, there are the fundamental constants. These are the numbers that tell the laws how strong to be. For instance, if gravity were just a tiny bit stronger, the whole universe would have collapsed back in on itself. A little bit weaker, galaxies would have never even formed. And third, you have the initial conditions, like that impossibly orderly state right at the beginning of everything.
Okay, so how in the world do you explain hitting a cosmic bullseye like that? Well, the first big explanation on the table is also one of the oldest, the idea that the universe was intentionally designed for us.
Now, people who support this view aren't just making a random leap of faith. They're using a type of reasoning that all of us use every single day. It's called inference to the best explanation. It's a cornerstone of science and, well, just living. If your car won't start and you see the battery's dead, the best explanation is the battery. The design argument simply applies that exact same logic to the whole cosmos.
So here's how the formal argument usually breaks down. Step 1. The fact that our universe can support life is so wildly improbable that it just cries out for an explanation. Step 2. The idea of a designer who could tweak the cosmic knobs provides a very direct and satisfying explanation for that fact. Step 3, and listen, this is the really controversial step, is the claim that no other natural explanation works as well. And that leads to the conclusion, the fine-tuning we see is strong evidence for a designer.
But, as you can imagine, a lot of scientists and philosophers take a hard look at that third step and say, hold on a minute. They argue that there is another compelling, completely natural alternative, and it just happens to be one of the most mind-bending ideas in all of science, the multiverse.
Okay, we gotta be really clear about this. The scientific multiverse is not the multiverse you see in superhero movies, with different worlds vibrating just out of phase. No. Real multiverse theories from physics suggest other universes exist in totally separate spacetimes. They might be born from things like cosmic inflation or quantum branching, and they are completely and utterly inaccessible to us.
Think of it like a lottery. If you buy just one ticket, your chances of winning are basically 0. But what if you could generate an infinite number of tickets, each with a different number? Well then, a winning ticket isn't just possible, it's guaranteed. The multiverse is like the ultimate cosmic lottery machine. If there are countless universes out there, each with different laws and constants, then a universe like ours isn't improbable at all, it's inevitable. We just happen to be the ones living in a universe that won.
So now we've got 2 heavyweight contenders in the ring, design and the multiverse. And this is where the debate gets really interesting. Because as it turns out, both of these powerful ideas face some pretty serious objections. The first major critique of the multiverse boils down to a really sharp question. Does the idea of a multiverse really explain why our specific universe is fine-tuned, or does it just say that a fine-tuned universe was bound to pop up somewhere, eventually? And critics will tell you those are 2 very different things.
Skeptics argue this way of thinking commits a logical error known as the inverse gambler's fallacy. Okay, Imagine this. You walk into a poker room and the very first hand you see someone get is a royal flush. It would be a mistake to conclude from that one amazing outcome that they must have been playing for hours and had hundreds of losing hands before you got there. In the same way, critics say we can't just look at our one perfectly fine-tuned universe and conclude that there must be countless other failed universes out there.
And there's another pretty big problem. Any mechanism that could actually generate all these universes, a sort of multiverse generator, would itself have to be incredibly complex and fine-tuned. Think about it. It's like a bread-making machine. For it to work, it needs all the right parts in all the right places and very specific settings. So this doesn't really solve the fine-tuning problem, does it? It just pushes it back a step. Now we have to ask who or what fine-tuned the multiverse generator.
Of course, the design hypothesis has its own powerful critiques that have been around for a long time. The 18th century philosopher David Hume made a classic objection. He said, look, if you can explain why each individual link in a chain of dominoes falls, you've explained the entire chain. It's kind of unreasonable to then step back and ask for an extra, single explanation for the whole chain. For Hume, the universe might just be what we call a brute fact, a chain of causes that doesn't need an outside explanation.
And this leads us to maybe the most popular modern objection, captured perfectly here by Richard Dawkins. It's the simple but really profound question, who designed the designer? If our universe is so complex that it needs a designer, then a being capable of creating that universe must be even more complex. And that being would then require its own designer, and you get into an infinite regress. The explanation, critics argue, ultimately ends up explaining nothing at all.
So it really feels like we're at a stalemate, doesn't it? But what's so fascinating is that the disagreement isn't just about the evidence. It's about the very rules of the game itself. What kind of answer are we even allowed to consider in the first place?
You see, a key ground rule for science is something called methodological naturalism. This is the idea that science, just by its very nature, has to look for natural causes for natural events. Now, this rule doesn't say nothing supernatural exists, not at all. It just says that science isn't the right tool to test for it. And for many scientists, this rule automatically disqualifies the design hypothesis from being a scientific explanation, by definition.
But then you have philosophers like Larry Lawden who push back on this. They argue that getting bogged down in defining what is and isn't science kind of misses the whole point. The real question isn't about what label we put on an idea. The real question is, which idea, no matter what you call it, provides the strongest, most satisfying explanation for the actual universe we observe around us?
And so, here we are, left staring at one of the deepest mysteries of existence. Is the precise, life-giving nature of our cosmic home the result of intentional purpose? Is it just the inevitable outcome of infinite probability playing out in a vast multiverse? Or could it be a hint of some new, undiscovered principle of nature that we just don't understand yet? For now, the answer is still out there, waiting for us, somewhere in the cosmos.